We have to tweet it as well, right?
Yeah, we are live. We'll see if it auto-tweeted. We'll go check.
What up?
Yeah. Sometimes it does, sometimes it doesn't. It looks like it did it. Yeah.
Yeah, it did it for me. Woo. Okay, I'm not wooing again. What the hell was that?
I mean,
God,
you're a woo boy. We know that.
I'm a bit of a wooer. Yeah. Well, you know, who came to visit the office today?
Who did?
Glauber from Terso came by to visit today.
Oh yeah.
It's good to finally meet him. Another database CEO on Twitter.
Yeah. Now he's a Texan, right?
Yes. Becoming American, coming down from Canada. Something someone else should consider doing, maybe.
You know, I told somebody on Twitter did like the same video conferencing with SQLite thing with the Terso databases, and I told them you should do frame per database, since you can split databases so easily.
Someone, one of the new engineers on our team did the whole like streaming thing on Turbo Puffer. Like it just like it lags a little bit because we have to sync to S3, but like it totally works.
It works. It works. He did tell me that the highest, like his largest customers, like database count, and it's bonkers. He also said he will come on this in a week or two, or whenever we do the next one. So we'll get a good net. Yeah, we'll get a good.
Is he in the hundreds of millions?
I can't say. I'll let him say. But it's a very impressive number, and it definitely kind of shows why the architecture is the way it is and why it's like valuable.
Cool. Yeah, we can have him on for sure.
How's your week been? What have you been up to since we last chatted? This is actually, we haven't chatted since we did this, have we? Unusually, we texted a bit, but we haven't like.
I don't think so. I think this is the main way we see each other now, Sam.
Living in public like Big Brother.
What have I been up to? Did a talk with the CMU seminar yesterday. Which is like as someone replied to me, it's like that's like the Super Bowl. I think like those are like the talks that I grew up watching, just like as a database nerd. So it was really special to actually go on and talk about the database that we're building. I've watched a lot of those talks too as I was building the first version of Turbo Puffer, because like you just spent more time operating and building on top of them than actually building them. Yeah. So I just did a super like honest walkthrough of the good ideas of the first version, which was just written in a cabin in Canada, to V2, which is gardened by actual database professionals. But there were some good ideas in V1 that have made it into V2. And so just talking about sort of going from just managing raw files on S3 to actually have an LSM key layer on top of S3, and lots of the other improvements that we've made. But I think every database has its own story. And I think that the story is very impacted by, you and I have talked about this a lot, the kinds of people who are working there and the DNA of them, right? So some databases have an academic beginning, right? Postgres is one of them. Others have a commercial beginning from day one. Oracle is one of them, right? Turbo Puffer. Others are extractions out of companies. I think ClickHouse is a good example of that. Like, I think Elasticsearch is a little bit of an example of that. Kafka is an example of that.
I don't actually know what is the origin of Elasticsearch. I don't actually know.
I think that Lucene started first.
Yes, I know that.
I think Lucene started first. I don't know what the origin of Lucene was, but as far as I understand, Elastic was written by the first version, Doug Cutting, for organizing his wife's recipes. If I'm not like completely mistaken, like it was like something like that, or maybe that was Lucene. It's like one of the two. Yeah, that's love. So maybe that's another reason, is just love as a reason to start a database.
That's so good.
So there's lots of different. So I was just going into that and some of the napkin math behind Turbo Puffer and why the moment was right. And yeah, I had a blast. It is so much work to do these talks.
Yeah,
I always forget. And my process on doing talks has always been to do a rough enough the slides, and then do the presentation, like just start doing it. And then usually doing the first few runs, I'll be doing so much reorganization as I'm doing the presentation that I just don't even finish and reorganize, like try to find a narrative. And it takes me around 7 run-throughs to actually do the talk. And in between, I'm spending hours on reorganizing the slides. And this one was no exception. And so when it's a 45, 50-minute talk, it's like, 7 times roughly an hour per run plus all the other time and like getting the benchmarking. Yeah, you're getting close to 15 to 20 focused hours to do these talks. It's grueling.
Plus, it's an audience that
I have a talk coming up at SRECon in 2 weeks called The Evolution of Postgres Performance. And I'm supposed to do a bunch of benchmarks for Postgres for it, which I've done a lot before, but I have a lot more to do. And I need to get on that. And I'm like, this is going to be a lot of time. But the nice thing is you can write all these like harnesses with AI like way quicker than you could have even a year or two ago. So
I really stress myself out by saying yes to talks. Like I just so stupid. It seems so easy to say yes. And then as it creeps towards the time you have to give it, it just gets worse and worse. I'm sliding everywhere to my desk. It's just, excuse me. Yeah, it's terrible. Plus, if you're doing CMU, that's an audience that like
there's no. It's like
bullshit.
It's a very particular and you can't really you can't really recycle very much, right? It's a very particular audience. So how many talks do you do a year, Sam? Like unique talks, like not just repeating it.
A couple last year, but this year I've got like 5 lined up. I tweeted that I would. Yeah, I tweeted that I was. Like now we have the Postgres product. It's like I want to come and talk about our experience at scale, massive scale, and what we're learning about Postgres. Turns out it's quite interesting because I got like instantly accepted to like 5 different conferences, including PG Conf, which is the big one. And so now I have to really like do a very good talk. And obviously I want to, but I just like, I struggle to get it down into the medium of talks. Like I can never time, I can just get it. Same with you. You got to just go through it so much. I can never time how it's going to lay out. And I just fuck it up every time, but it's fun. It's still nice to get there and engage with the audience and stuff like that. And I like ones that have demos. I love doing demos. That's my favorite.
I think also it's just so good for onboarding inside the company as well. Like our sales team will be watching these talks, right? The engineering team, as people are getting to know the database during the recruitment process. There's so much value to these over time for hiring as well, as people get exposed to how this company is actually thinking. Yep. So it's something I've been doing for more than a decade now, and I really like it. And then also just because when you come down to it and you have to articulate something, you have to write something and try to condense it into a narrative that is memorable. That also becomes very important internally, and it takes a lot of time. Like a lot of the Napkin Math was actually originally an SRECon talk.
That's right.
In 2019, it was a talk, and it was just. I'd like been using these numbers and roughly referencing them, having them like in a shitty file somewhere on my hard drive. And then actually, okay, like I'm going to do the GitHub repo. I'm going to put it up there. All of that just it's just a phenomenal forcing function for some of these side quests.
What is your favorite tech talk that you've watched? Not that you've given, but you've seen. It doesn't have to be live. It can just be recorded.
Just any of the Jeff Dean talks. About how they scaled MySQL for the web index or whatever they were using it for early on, and just how systematic he is. Like he's just like unequivocally my biggest software hero, because he can go through the levels of abstraction to a point that almost no one else can. I think you and I have talked about how the p99 is very good at seeing a couple layers below where they're working and a couple layers above where we're working, right? Well, Jeff Dean sees like 12 levels below where he's working, right? Like he will go over and it seems like play ball with the chip team, right? And on like, what are we going to need? But then also can understand the models and presumably all the way up to the user. I think some of the most, like if you want to talk about not just the p99 engineer, but the triple 9 and the quadruple 9 engineer, they just traverse the abstraction level between 10,000 feet and just like a nanometer seamlessly. And I think Jeff Dean just does that.
He's got a P100.
I mean, I think he is. Yeah. I think he is P100. Yeah, he is P100.
Thing is, though, that's this is a controversial take. And by the way, I'll tell you my talk, which is very thematic to Napkin Math, is complete like opposite of what you're talking about. But I think he is so good, and some of the core people that work around him are so good that has denied the rest of Google the ability to get like a lot of people to get that good. Like he has centralized such incredible systems built by him and a tiny team that it's almost like a nanny state for everyone else, right? Like you don't get, like you just get the services you get to build that he is like, and his team have orchestrated. It's very interesting what it's done to their tech culture. Extremely interesting.
I mean, I don't know anything about Google culture, but I've certainly observed that myself inside of like fast growing companies where you will have a couple of people who just get so like, they just get so good because they're tapped into so many feedback loops at once, and they keep getting tapped for the most interesting, like most, sampling efficient projects. And so there's a power law to where the learning goes in fast growing companies, which just goes to show again, like put your hand up and deliver, because more and more will go through. And then I think they also hook into a lot of learning streams, right? Like Jeff Dean is like hooked into the learning stream of the chip design. He's hooked into the learning stream of the database design. He's hooked into the learning stream of the models, right? So he's hooked into all of these. So now he gets to learn, not just like with one training loop, like he has like an H100 plugged into every team, right? And just like, he's just sampling from in there. And I think that happens in almost every company, but it's also something you have to be careful about, right? Because now you create these bottlenecks.
Yeah.
The other thing I love about Jeff Dean is he's actually on Twitter. He's like, one time I like tweeted about the spanner paper, and he like hopped in my replies and like said something or corrected something or whatever. I'm like, oh, you're here and you're paying attention to everything people are saying.
He seems very approachable.
You've gotten in.
Yeah.
Yeah. Ben, you got to try and get him on here. Then we'll try and get Jeff Dean here.
Yeah.
Simon, go do it live from the Googleplex.
That would be great. Really that would be great. Yeah, I'd fly in for that. Yeah, I mean, like he also one thing I remember he doesn't do a ton of podcasts, but I was listening to a podcast with him as I was just like in my Jeff Dean absorption phase, where he was talking about Google Translate and how Google Translate had sort of evolved from, they would just slab another, like, okay, we're going to build this service and it's going to do this like crazy synonym. I don't know. This doesn't matter, right? But like, you can imagine Google Translate just morphs into like 1,000 services that are all providing like little 0.5% improvements. And then he's like, okay, yeah. And then, we went over and did TensorFlow, started training models. And then with 100 lines of TensorFlow, we can train a model that could just replace all of that shit. Just unbelievable, right? Because now you've done a complete reset in complexity, and then just imagine where you can go. And it reminds me of like a pretentious analogy here, is like going from like the air balloon to the airplane, right? Where like the first airplanes were just objectively so much worse, but they just had unlimited potential. So when you ask the Wright brothers, like, okay, dude, this thing can barely fly, like probably a month, as so many people are going to get killed, right? And he's just like, yeah, but the air balloon has like exhausted its potential. This thing we could continue to do R&D on for the next 150 years, right? It's like, yeah, we still can. Everyone's still excited about what's to come in aviation, right? And so I think that's similar with the Google Translate, where, okay, there's like a full reset in complexity here, and now we can just let it rip from here as we reset the complexity graph. Same with like gas engines into electric engines, just full complexity reset.
Speaking of P100 engineers like Jeff Dean, we have another P100 engineer hopping on the call right now.
Oh, wow. Who do we have? Special guest. We pre-announced this, so
we've got Daniel. Or maybe
I would not go that far. Maybe not that far.
Famous for hating the P99 though and wanting to drive it down. That's for sure.
That's true. Yeah.
Tell us about yourself.
Doing?
Thanks for having me on. Pretty good. I'm wearing stuff.
Very nice. I need to buy some merch.
Nice. Yeah, introduce yourself, Daniel.
Yeah, so I spend most of my day thinking about performance and fixing performance, and therefore tweeting about performance as well. Yeah, so I used to work at Ghost. I worked at Ghost for 5 years. I was technically a DevOps engineer, but really I was just all over the company doing sort of general software engineering. It's actually where I met Simon for the first time. And then left last May to go freelance. And now I work with companies, small, medium size, on all matter of things, performance, scaling, and cost. And yeah, I mean, I get my dopamine from performance. So kind of it's the perfect job for me. And tweeting about it is nice, not only for good marketing for me, but maybe to encourage others to do the same. And it's amazing, honestly, like the amount of people that tweet me now and or email me with graphs. and I just retweet.
It's so
obviously.
funny. I do
You're
love
just like the
seeing that.
default guy. Anytime there's a graph with a drop in it,
Yeah,
just like at Daniel.
yeah. And I've tuned the algorithm well. It now delivers good content to me on a daily basis.
You know that you can ask the X engineers to turn on some flag for you so that it's not what you actually engage with, but what you're liking and doing, like more explicit, so sort of the implicit versus the explicit signaling. There is like, if you find an X engineer, ask them for that. Because obviously
I do have some in DMs. Maybe I'll try. Yeah. You
should, because implicitly you just end up with a lot of people who are fighting at gas stations, right? That's just like, just in the limit what you want.
Yeah, but it means you've been liking them at some point, surely, or at least watching them. Those videos, we all get them. They're all good. Are they testing something then? Is the reason they have that mode because they're trying to get to that, Simon?
I don't really know. So I had an idea. I don't know if we talked about this, Sam, but I thought it'd be really funny if Daniel would roast our websites.
Oh yeah, yes, please.
What do you think about this? So I think maybe Ben, maybe you can pull up the screen share the Planet Scale website, and we can get Daniel to start roasting it.
Yeah,
you know, the problem is though, I'm probably like the perfect like customer for both of your companies.
You could love it too. You can say what you love about it.
I did run into a bug with Turbo Puffer website. Maybe I should.
Oh yeah.
You know.
Okay. Roasted.
Well, like, save the roast for when it comes up. I can't wait.
I think let me get it up here. The problem is, I think Daniel needs to be like staring at the network tab in order to properly roast a website, right?
Yeah, it's true.
So maybe he can swim.
Oh, I see. You want to roast the perf. Okay. Well,
but I'm still going to screen
fast if it's a fast website.
Oh man, I don't have the permission set up to screen share.
Oh, security.
Oh,
I got it. Keep chatting.
Okay, you got it. There we go. Okay. You got the permissions?
I have to restart my browser. So
let's just start at the meta here, Daniel. If you're asserting a website and you're trying to figure out if this is a website you're going to choose, what are you going to care about? Like before you even go to the website.
Great question. I think you know, for me, all the flashy stuff doesn't really sell me. I like to see graphs and I like to see numbers. I think I'm kind of overwhelmed these days with the amount of flashy animations from AI and scrolling effects and all that kind of stuff that I just get annoyed and I just want to see like, okay, does this product actually work? I think I've seen a lot of people, my friends included, that go for like the flashy options of websites or products. You know, they get like a couple of months in and then they realize, oh yeah, actually it doesn't work. And had the website actually told them maybe the drawbacks up front or actually what the product even does, they might have chosen a different option from the get-go, hence saving them months of time, money, engineering time.
What's the worst offending stack or pattern or framework that you fix and improve?
I mean, the most common one that comes towards me is definitely the Next.js world. Well, JavaScript's in general, and Next.js is definitely the largest. Yeah, I don't know whether that's because
that's something inherent to the framework, or is it just more people not knowing what they're doing, or like vibe coding things, right? And then performance is terrible.
Man, there's a lot of vibe coding these days. Not only amongst my clients, but just everywhere is just vibe coding, right? And I think with AI, it makes the whole thing worse by default. AI, in my experience, is very additive. Like it just adds code, it adds things in serial as well, which I find causes a lot of these blatant performance problems.
Oh,
you know, like
right.
In the JavaScript world, you know, it does like 2 or 3 or 4 sequential awaits, whereas it should probably like a promise to all or something like that. You know, like really basic things like this that you know I know not to do, and maybe with some skills.md, you know, AI should know not to do, but yeah.
I mean, I feel like most websites that have been written are doing a lot of just serial database calls, and so maybe that's just what it's been trained on. I think Sam and I were talking about this recently, and this is why, you know, we're not just talking about the p99, because like the reason we talk about the p99 is because when you are doing so many sequential database calls, the p99 just matters so much. And I think most people spend a lot of time thinking about the P50, but when you're designing a system, you want to think a lot more about the P99 for that reason.
Mm-hmm.
Average
Yeah,
user,
actually, I can't remember who tweeted this like a couple of months ago, but they were like, "Oh, you should like post more P99 graphs instead of P50 or something." So I think since then I've basically only posted like P99 graphs. It's cool. I mean, I don't really care myself as long as I see some sort of graph drop. But yeah, P everything drop.
Are we ready for the roast now, Ben?
Roast us.
Did you get the permission?
Roast us.
Oh no, I have to like sign off and sign on in order to do that. I'm pretty sure the stream will still go, but I don't want to risk like closing out the stream.
Okay, so what do you think? Do you think I should try to share
Someone else would have to do the screen share, basically.
Okay, let me see if I can. Let me see if I can do it here. Don't show these tips again. Okay, here we go. Starting with planet scale.
Ah, there we go.
Okay, give it your
light
worst.
mode. No, don't make me look at my own website in light mode. Come on.
You want to switch? You want to switch
Yeah,
it?
I don't want to switch it.
Okay, here you go.
Look at that.
I'm now a system mode person. For the longest time, I was dark mode, and then now I'm like, maybe system mode is actually better.
Absolutely.
I'm
like
system mode all the. Yeah.
By the way,
Oh, yeah.
I bought that stupid Dell monitor, the giant 56 or 52 inch monitor, which is like a cubicle wall. Like right now, I cannot see anyone else in this office because of it. And if I tab to a light mode website, and I also, by the way, I think Simon knows of it. Like I've suffered from migraines for like 20 years. Like if I get a camera flash, I will see it for like an hour, right? And so now I'm in this situation where if I tab to a light screen, it is genuinely like getting like Call of Duty flashbanged or whatever. It like actually just affects me. So now I'm fully dark mode for everything I can possibly get to. But anyway, carry on, Daniel. I just wanted to share how dumb I've been with my hardware purchases, and now just like I'm damaging my vision from it.
Do you want me to roast these then?
Yeah, now it's time to roast. Yeah.
Yeah, guys, honestly, I'm the worst person. This is not like my girlfriend is a designer. She's the person to roast these things.
Bring her into the room.
Future guest.
I know performance, man. Like I
The one thing I will say about this, and it's actually the same for the Turbo Puffer website too, is like even with I just got a brand new laptop, like incredible CPU, and I go to landing pages and it like jumps and jitters at the moment I start to scroll. I just like can't stand that. I'm like, this never happens on planet scale, right? It's always it's basic.
It's going to be hard to. What's going on? It's going to be hard to roast two very simple websites. We could roast a lot of other landing pages. By the way, when I go down someone's landing page and it starts lagging, it kills all trust I'm going to ever have in the product. Like it really bothers me. It's the worst thing ever. Like to see that stuff. Why?
Have you guys cross-roasted each other's websites? Like, given you have very similar designs of websites with slightly different.
I mean, I think there's too much text here.
Yeah, I agree with that. By the way, it is getting too hard. This was great when we had one product, but now we have three. It's very hard to communicate.
Like I want some components here, with costs. Like I'm like at this point, I'm just like I feel like I'm reading an article.
Yeah,
Daniel, I'm just taking over for you here. Like you're being too nice.
I agree.
Go to Turbo Puffer. I do love how like right on your landing page you have a cost calculator, which is, I mean, it's one of your strengths, right? But it's like very just like to the point, right? This is what we do, and then you just like tell us, boom.
Can we just scroll up to my favorite bit of my website first, though?
I really like the footer. By the way, I think the footer is great.
Oh, thanks for that. The link to the trust center is your best bit. Look at those logos. That's the best part.
What is your trust center? Let's look at your trust center.
Oh God, now we're gonna. Why did I say trust? Kick it. Yeah,
okay.
Look at that.
All right. SOC 2, Type 2, SOC 1. Oh, HIPAA.
PCI. That's the impressive one. That's way hard.
PCI. That's actually really hard. Pretty clean on the subbies. Yeah. I mean, this is pretty good.
Approved.
Okay.
Thank you.
Sorry, where do you want your favorite? Is it a logo wall?
That's what we should roast. Other people's sub processors list. That would be quite funny. That would be quite good.
That's
Why
actually
is
really
Datadog-
interesting to find out what other companies use.
Yeah, it is a good
That
way.
you can kind of like get intel on them.
Yeah.
Okay. Do you want to roast my website now?
It's hard to roast your website. It's very good.
I don't know. I could roast it myself.
Ours does need. Ours is getting a bit of a redesign, by the way. Just to leak that, it's going to have to improve a little bit.
I think you need some components on it. You need to just like break up a little bit from the text.
Yeah, you got to remember. Do you know the first version of this was done while I was in a cabin near wherever in California that giant tree is, General Sherman, in a Google Doc. I literally just I could find the Google Doc where the first version of that website is, and it translated from there. And yeah, it definitely needs this is a good logo wall too. Ooh, very tasty, very tasty.
Okay, I have one for Planet Scale based on this one. I think the logos are better sized on this one.
Fine.
I think there's a lot of real estate spent on Planet Scale. But what do I know? As I said, I know performance.
Yeah, you're the ones who cuts everyone's design back for performance.
Yeah.
Okay, but so what do you think about this for performance here? Do you feel satisfied?
Yeah. On the right, you mean?
Yeah. This is
I guess the
sufficient.
question is like, because there's the performance, which that's just your performance, but like one of your big things too is like your cost to performance ratio, right? Because there's probably other things that have more impressive performance numbers, but it's the fact that you're running on S3 and the cost is like an order of magnitude less, right?
Simon, can you also define what warm and cold means in your world? Like a warm namespace and a cold namespace in the Turbo Puffer world. Oh, okay. Yeah, you tell us.
Yeah, we should this copy should really be shorter, right? But our latency distribution is trimodal. You have hot, which is in memory, warm, which would be an NVMe SSD, and then cold, which is everything is in object storage. So it's trimodal. Here we're only showing in memory and in object storage, right? So only bimodal distribution. And that's what we see here. So cold for us means everything is in S3. Like not like there's like nothing, none of these like 3 gigabytes are present in cache, not even the smallest files. And then warm means that everything is in memory more or less. Yeah.
Simon, do you have price comparisons versus other solutions?
No, we don't. You want that?
I mean, I think if you're going for the 10x cheaper, as it says at the top, it'd be good to know in comparison to.
So here's my reasoning for why I don't. Right? We don't talk about our peers, and the reason why is that as soon as you start doing that, you kind of open yourself up to, well, like you should tune this setting, and why don't you tune this setting, and it becomes this like back and forth. And so I would rather that people do the comparison themselves, go and see if they can dig up a pricing calculator on the other website and then do it, but not try to contrast ourselves here and just start playing a game that I'm just not interested in spending the dev cycles on. Because sure, like if someone comes with a valid retort of, hey, you should be tuning this, you should be doing that, this is not apples to apples, then to have like to keep our integrity, we would need to actually do all those things. And so it's just an enormous amount of cycles.
Yeah. One thing I've been curious about is I think the initial motivation for Turbo Puffer was your time at Readwise, right?
Yeah. It was. I spent a few months doing a little bit of consulting with them to fix their Postgres. Yeah.
And I think the number that you put out at the time is like 30K a month or something on, I think it was Postgres, right?
Yeah.
Using Postgres. Do you know what the equivalent number is on Turbo Puffer? Like what is it now?
What is Readwise bill with Turbo Puffer?
What for that workload of 30K a month? What was the equivalent if it magically came into existence? Turbo Puffer.
I would imagine it was a few $100s a month, maybe high hundreds of dollars a month, maybe very, very low thousands. Yeah, I wish I had the notes still from that exact workload.
That's wild. I love a good
Crazy.
saving story. The best
Yeah.
one we have is that we moved a cluster from EBS to Metal, and it went down in cost just for the infrastructure, not even the plant scale part of this. $19,000 a day. That is when you run like massive workloads on EBS. EBS is unbelievably expensive, especially IoT.
It's the IOPS, right? It's the IOPS. It's the IOPS that are costly, no?
It's IOPS when you get to like you want 16,000 or more IOPS because you have to go to IO2. So that 16,001 IOP is like $2,000 more than the 16. Like it just jumps like it's wild. And then like
Sam, why
GP3 actually goes higher now, but it's just the
Oh.
latency is so much worse. So like most people, if you really want performance, you're still going to pay for IO2, which is like way worse than a local disk.
Why are RDS and like the hyperscaler equivalents of running Postgres are all on network devices still? Why, right?
Yes.
Why?
I think it gives them a much more convenience and takes a significant amount of their problem. Like it's very simply from what I can gather, which is like every org runs, which is like another team has kind of solved this thing, so why not just use their thing? You know what I mean, right? Like it's just like kind of that. Although they had to diverge a bit for Aurora because it needed a like different sort of file system than EBS, so it doesn't run on EBS. They have some duplication, but I genuinely think it gives customers what they want. It does actually have one property that Metal has started to have now and is going to continue to get better on, which is like you can have varying granularity, meaning you can like have a tiny amount of like the one way we sometimes get workloads come into us and they'll have like 30 terabytes of data, but very like tiny QPS or like, and they just really don't need that CPU and compute. We have to give you big boxes to give you 30 terabytes of data, and it's very expensive in comparison. And so it gives you that, it lets you have that kind of granularity. And yeah, like it's the cloud, right? It's like a very failure prone environment. I think it just reduces the cognitive overhead they have to build those services.
And we put a lot of engineering effort into protecting you, since like if you have a fixed size disk, like we have put a lot of thought into like how to handle that gracefully or how to auto scale disks or how to get you upsized, right? So that just takes a lot more effort too.
Daniel, what's the biggest cost saving that you see? Like when you log into a customer's AWS or GCP or whatever console, what stands out to you as one of the really common sources after NAT gateway?
Honestly, at the minute, I think it's LLM costs, which I don't know if that really falls into the AWS bracket.
Nah, it's boring. Everyone's paying up the wazoo for tokens.
It's insane. You know, I only got into that world like a couple of months ago. It's crazy numbers, like maybe orders of magnitude more than your infra costs.
Yeah, like you're hearing of startups who are spending like with small engineering teams spending like high tens of thousands, low hundreds of thousands of dollars per month on tokens.
Yeah.
And everyone's just like, go.
And in comparison, the infrastructure is cheap. Like, who cares? You know, like the LLM costs are many times larger. Yeah.
I like our bill going up. COO doesn't obviously, but like it's a good sign, right? Like the usage going up is good. It multiplies. You know, ILM cost is definitely like rocketing up quite a bit. Like you see a lot more of the emails of people wanting a bigger increase, right, in their bill or whatever, like in their usage per engineer. And I'm happy with it. Like it's making people that are very hard to find very productive. Like it's great. But like I don't know if same for you, Simon, but like effectively we have two costs at PlanetScale and everything else is a rounding error. It's our cloud bill and our wages, right? And so like LLM's becoming the third, like it's like probably second, right? Should impact both, right? Like it should actually grow. If for like companies like ours, it probably should be a strong third over time. You'd hope.
Yeah. So you don't see any grave errors there on the like. So when you're helping companies trying to reduce their cloud bill, is it mostly as a side effect of improving the performance of the application?
No, that was my jokey answer. The LLM costs. The costs that I do see are sometimes just forgotten infrastructure, things that people turned on once, forgot about it. And I don't know if you've tried to use some of these dashboards; they're not the easiest. Simon, I think at some point you said you have some script to like pass the AWS reports or something, right?
Yeah.
Yeah, just understanding some of the AWS billing or GCP billing pages is hard enough. Outside of that, I think I see a lot of customers massively over provisioned. Maybe like Cloud Run instances that are like, maxing out at like 40, but they're always running 40 because of some app infrastructure problem. Sorry, some app performance problem. I came across somebody recently that had 40 Cloud Run instances running all the time to handle 20 requests per second.
Nice.
This is very common. This is normal.
Have you seen people fall into the trap of thinking they have like a really efficient configuration?
Yeah.
Like auto scaling, right? Like we've seen so many people with like massive RDS bills or whatever because they have auto scaling turned on, and if they would actually just turn it off and choose like because that means their unit cost is higher because of the auto scale. Like it's such a weird thing. Like Amazon have managed to come up with a way of making people feel much safer. Like people don't want to overpay for resources that aren't being used. But the unit cost being higher means they net out spending more. It's pretty crazy how that's worked. Do you see that?
Yeah, and I think even the presence of there being auto scaling in a system gives people the like comfort in their brain that our system is auto scaling. Yeah, it's auto scaling like 10x larger than like it probably should be, right?
Dead giveaway that you haven't been on call long enough.
Yeah, scaling is kind of bullshit, honestly. Like so many people believe in it like so religiously, and they're kind of trying to optimize for like certain spikes that happen, and you look at the spikes that they have and you're like, no auto scaler would respond fast enough to this spike. It would still be down. Like
Shopify never auto scaled. It seems like the most auto scalable like workload in the world. It's like, well, when you have an event where you go from like a few thousand requests per second, hundreds of thousands per second to into the millions, you don't have time to auto scale. So this is like you have like two solutions when you're under pressure, like shed the traffic that doesn't matter or wait like minutes on scaling. And so you kind of have to get good at both. And I will invest a lot in one over two any day of the week. Because most of the time when you get spikes, there's a lot of like junk.
Yeah. So
the third option you have is degrading the experience, right? So more aggressively tuning the caches.
Middle of last year, I was working on Fargate, AWS Fargate, which is like that container runtime platform thing. And I discovered that the minimum spin up time was like 3 minutes or something. Like after you receive some sort of spike, the amount of time it would take for this platform to, realize there's a spike and then start spinning up the containers was 3 minutes. So like, man, the spike's probably over, whatever. So
talking a customer out of auto scaling though is so hard. Like we get people come to like, because we have it, right? But it's still, they're really talking, we end up having this conversation, right? Because like you don't want to let them down. And there's just so much belief in it, or so many people being like, we don't want to pay for wasted resources. And it's just like, you are not really like, okay, it goes quiet on the weekend, but you're able to eat spikes during the week. Like it's just, it's such a,
Well, one of my favorite graphs that I made was where I made the app so performant that it stopped auto scaling and it just sat at the minimum number of instances. And then I showed it to the client and they were like, what happened? Like, is it still running?
I love it.
Yeah, like it encourages bad design patterns too, because you can just get away with poor app design and plus ones, all that, and just like, the autoscaler handles it.
And it's actually quite good to have limits. Yeah. Carry on, Simon, sorry.
No, I was just going to say that another one of these buttons that people really want to press to feel safe, but that doesn't really do anything, but that costs you a lot of money, is the spreading your workload across AZs. Right? Because if you're in a single AZ, everything like your IP goes into that AZ and you're just like in that lane the whole time, there's no networking fees. Latency is lower, right? Like as soon as you cross AZs, you go from like a couple hundred microseconds, right, to maybe a millisecond or two to cross the AZ networking. it is so rare that I see single AZ outages. Like it's just like it's very, very rare. I think a lot of like this is not like overall advice, right? But it might be it's just very, very expensive for people to send a lot of network east-west across these ACs. And the clouds will happily sell it to you, right? By default, they'll just distribute all the machines. Depending on the shape of it, it might not matter for performance and it might not matter for networking cost, but it's pretty dramatic, right? Like if we were not smart around that at TurboPuffer, it would really hurt our pricing.
Yeah. It is wild, actually. The price they charge for any of this networking bandwidth or whatever, the markup is unbelievable.
Cent per gigabyte, right? Cent per gigabyte over like these like massive like 100 gigabyte per second NICs, right? I think it must be like, I'm guessing it's a 90+% gross margin, if not higher on the list price.
Yeah.
It's like absolutely abysmal.
Yep. Crazy. Absolutely crazy.
And then the NAT gateway, right? Like for any outgoing, where they charge, like the fees on that are just like, it's really, really awful. I just think most people just don't understand networking very well. And so you're just like, well, I guess this is just the cost of doing business. And I think people miss it they miss it. They just miss how expensive it is and they don't design for it. And you just press the button.
I wonder if someone released a cursor skill that just looked at your infrastructure and just like magically could just get it exactly right sized, and everyone on earth to install this skill and right size their infrastructure. How much do we think the cloud's revenue would drop? Probably 50. We must be 50 as an industry, at least 50% over provisions, right?
Probably. We're not. You're probably not.
I don't know. Yeah. I
mean, at a certain point of scale, right, you are spending significant amount of resources on this, right?
We have to do it.
I'm sure you're missing things too.
Everyone. I remember I ran up 140k S3 bill at GitHub, like because backup retention, like pruning broke. And like one of our new guys joined and it was just like, oh, have you noticed this was happening? And it's like, and so I just deleted a ton of,
I mean, beautiful. I think also people like, there are very, very few companies in the world that run on high utilization on the boxes, right? If you read between the lines of a lot of the kernel improvements and the really deep engineering blog posts that come out of Meta, for example, a lot of that sort of suggests like, okay, we're running all the boxes at like 80 to 95% utilization. That is like the equivalent on driving on some of these roads, right? Where it's just like you're single lane and like half the tire track is like off the side of the mountain. Like this is like very, very, very delicate engineering to get right, to run at 80 to 95% utilization. Because if you go even to 100 for like a few seconds, it could completely stall the node, right? The consequences of this are really dire, especially on a database. But the cost savings of going from 50% utilization to 80 to 90 are just too hard to ignore. And so they just spend so much time on like CPU kernel scheduling, right? And like building all of this stuff into the OS layer so they can run the boxes at these utilizations. But there's probably only like a dozen companies in the world that are good at this. It's just so unbelievably difficult.
Also, I pulled up this audience question just while we're on the subject of like storage and crossing AZs, but I think this is more oriented towards Sam. Like, what do you think about like offloading cold data to like cheaper storage? I imagine S3, it's kind of like what you're doing, Simon, with TurboPuffer.
It would. I mean, yes. I mean, but it sounds easier than it actually is, right? Like, actually tiering relational workloads that way is not easy. And like relational access patterns can change dramatically. And just like, I mean, we've all seen this with relational databases, even just cold data being like on disk. Like I've given this example before, I think like back in the day when people used to go through GitHub stars, right? Like by the time they got like to the 20th page of Twitter Bootstrap, right? Like it's not in memory anymore, right? And so like if people are doing that concurrently and start tying up like threads in the database with significantly slower IO, you're going to go down, like the whole database server is going to go down. And then like at that point, who's at the scale where this is worth it? Like most people are at a scale where you can just buy a host where it's all on the box and doesn't need to go off to S3. It's better if you're like turning the databases off, like you would with like a scale to zero architectural stuff. Like that definitely does work. But I think for like a live, like it's just not enough of a saving for the potential downside of just having very variable, slow costs. Like for another example is like, if a query is joining on data, for example, and doing a lot of seeking out to another table, and that table is cold on S3, you are suddenly dragging your performance down again for a small amount of savings. Like OLTP, if you truly have an OLTP workload, which is all you should really be putting in Postgres and MySQL, it's a hot workload. It's a very live workload, and it's also PlanetScale says a lot of very big numbers for OLTP, and they are incredibly impressive for OLTP. But OLAP workloads dwarf those inside. Like some companies can have massive OLAP workloads, and so yeah, an OLTP is a hot workload. It just truly is. It should be on the hottest storage you can afford, and you will save in other areas as well. You'll have less front ends if your database runs faster. That's like, people don't realize that when you're sitting and waiting for the database, you're just like web workers or whatever are just sat idle. That's more front end capacity. If you let the database execute faster, you can deploy less elsewhere and just save money elsewhere in terms of like ship features faster. It's just not the place to really try and save with tiering. Turbo Puffer, and I can say this because we share a ton of customers, they have massive amount of data because what they do is vectorize everything, like literally everything that could piece of information that company holds that doesn't live in a relational database. You need those dynamics, otherwise it's like pointless, and otherwise you have to solve the harder problem of what to vectorize. You know what I mean? Like if I want to do a gnarly search back through all of my Notion documents, I want it to hit every Notion document. And so the cost dynamic, tell me if I'm wrong, Simon, but the cost dynamic is so crucial to you so that they can do that, so they don't have to make the trade-off decision of deciding what will end up in these hotter systems.
100%. I mean, like at the end of the day, right? You have to either trade, forget about cap. Like what you're really trading off here is like risk and cost, right? And so if you wanted, what you could do with a relational database is that you could decrease your risk by running on 2 replicas instead of 1, right? Or you could run replica and then like async put into like a backup or something like that. So that would be like the natural extension where you're just sending a replication stream off at S3. But now you're increasing your risk because failing over now is taking in the tens of minutes, if not hours, to restore that backup. So increasing risk is very problematic for OLTP workloads. Like you're just not going to do it. And then the second option is that you have another storage engine, right, for a particular set of tables that have fundamentally different access patterns. But at this point, you're building another database inside the database, and all of the advantages of having the data co-located really start to disappear, because if you're now starting to join a table with different performance characteristics, like you're just going to take the whole thing down. And by the time you're at a point of scale where you have the staffing that you're going to need this and all of that, like someone is going to do that and it's going to take down prod. So it does help you to separate it, even though in the limit you could imagine a database that will do this well. It's just such a massive R&D investment that it's worth another company to handle it. So I don't really think the tiering makes a ton of sense for the OLTP workloads that I've dealt with. Like coupling storage and compute there just makes perfect sense to me. And then putting these tables off. But we are seeing some companies that want to use TurboPuffer as a source of truth for particular sets of data. So for example, if you have something like, let's say you're like indexing articles on the web, right? You have like a massive catalog of articles that you want to save. Having that in Postgres is quite expensive. Like that's like a lot of data. And you're okay with these random reads taking maybe 100 milliseconds or whatever. Now you reduce your Postgres size by like 80% and moved it into something like TurboPuffer that can do these random reads like quite well. And you're controlling the join characteristics, right, in a way where you get the performance that you need. So like fundamentally, to me, there's like 3 different database architectures. There's like coupling of compute and storage. Then there is the decoupling of compute and storage. And then what I call TurboPuffer is that it's compute storage flexible, right? You can pin a workload and all of that, but you still have high write latency, which you're not going to want from your OLTP. So it's just like fundamentally a third and completely distinct database category that's really well suited for some types of analytics and search.
For what it's worth, I do see quite often people who have OLAP workloads in OLTP databases. That's very common.
It's so common, and you should start there, right? You start with the OLTP, you do the shit out of it, and then at some point you're going to have to move some of your OLAP data out, and you're going to have to move your search data out. Fundamentally, you're probably not going to need many more databases than that, right?
If we were like less honest about this, we would have we'd have made millions more in revenue by just we just often tell people this is an OLAP workload. Like you just like the more we can like shard this and you can continue on this journey, but this is like an OLAP. We did this with Insights, used to be backed by sharded MySQL because it's what we knew really well, and like we've shifted it out to ClickHouse, and it's cheaper, faster, more dimensions, better in every single way. But like we got where we were because we picked what we had. Like tech is so boring, really. If you think like that's actually kind of the thing that we circle constantly is like the physics and the rules has not changed. This is like we were talking about, one of the topics we could talk about today was edge, right? Like that was a whole massive thing. And then like Vercel were big on this, like everyone. And then everyone just admitted at one point, nobody has a workload where this is necessary. The trade-offs are just not worth it. Like there's very few businesses and websites that are truly completely global that can't have isolated infrastructure. Like it's just not, it's a made up thing that we all want to believe in. There was entire company, like so many companies founded on making databases work this way and all this stuff. And we got back to, you don't need it.
The trade-offs are not worth it.
Just not worth it. But people like to mess around. Like I just think people are kind of bored. They're just like, don't want to hear that there's rules, and those things kind of work, and you can use Postgres, MySQL, and bit of Memcache or whatever, Redis, and it just works. Like they want to believe that you can resolve these problems. We've seen some of that in the last couple of weeks of just whole new architectures showing up, which just make no sense. It's like, yeah, you can get like a incremental amount more performance if you choose this very constraining architecture, but if you get one more type of customer or do one more extra thing, it just gets completely thrown out. And that's why we've found these pretty generalizable architectures that work nicely.
I really, if I ever get the time, I would love to create like a periodic system of databases and what types of queries perform on different types of architectures. It feels like there is a way to like distill all of this down in a way that's easier for people to navigate. It's just so easy for us, right? Like if we're working on the equivalent of Insights, right? It's just like, oh yeah, this is roughly the data structure we need. Is it data element, this, that data structure? I could not reason like that 8 years ago at Shopify. Like it's just like, now it's just so ingrained. And I wish that it would be easier to try to explain that.
Simon, this is kind of related because I saw a little bit of that talk you did yesterday with Andy Pavlo's course. I feel like everyone in this room understands the like Napkin math latencies pretty well, right? And that's like extremely beneficial as a part of all these trade-offs. Like maybe you could speak to why is that so useful for people? Just like if off the top of your head, if you know the difference between the latency of an S3 write versus an EBS write versus a local disk write, like just having that in your head helps you make these trade-offs, right? Like so much better just on a day-to-day.
Yeah, 100%. Like before I had these numbers, I was just like, oh, if something goes to disk, it's slow. And it's like, it's really not, right? I'll pull this up again. I'll pull up the latest Napkin math numbers. I'm actually working on them right now actively because I was preparing for that talk. But I think,
although maybe all of my balls on the internet have helped others memorize it better, you know, doing
it's a good representation. It's a good representation.
I mean, yeah, Ben's balls rule the world. I think so. Like one of the things that's interesting here, right? We're going to call out some of my favorites. So here's like a sequential SSD read, right? Do this at about 8 gigabytes per second. 8 gigabytes per second to do sequential SSD reads. A single thread, just like raging through memory, can do 20 gigabytes per second. Now, of course, if you maximize all the threads in a box, you get in the hundreds of gigabytes per second, right? But it's like, this is really good. That's probably an order of magnitude higher for reading from SSD than most people would assume. Then there is also all these like blob object storage numbers, right? Like one of the things that's not necessarily obvious to people is that you have to use a lot of connection to try to maximize out the network. But I think the way that I think about these Napkin math is really important is that if you were trying to construct a system and you want to know like what the floor is, you're just not going to get there if you just look at a profile. Like if you're looking at a flame graph of like what the machine is doing, you're going to be able to like know, okay, what's the easiest change I can do right now to get a 3 or 5, if you're really lucky, a 10% improvement. But it doesn't tell you what the physics are capable of, right? Like if I know, like, okay, so I'm, doing a query and it's reading a gigabyte of memory, like it's reading a gigabyte of data, and my machine is taking a second. You might be like, okay, well, like I'm going to look at the flame graph. Okay, I can improve by 10%. Now it's at 900 milliseconds. But if you're looking at this graph, right, and you're reading a gigabyte of data, like a gigabyte of data, if you're maxing out the entire machine, should take 5 milliseconds, right? So like this is your North Star. And if your thing is taking 900 milliseconds, like you are so far off, and you're just never going to get there by iterating on a flame graph. You never are. Like you have to rethink the entire system. And similarly, right, if you're doing that, you're like, okay, well, even if I did this on disk, it's going to take 100 milliseconds. So it would be an order of magnitude cheaper, which you can see, see down here, right? Like SSDs, ephemeral SSDs cost about 10 cents per gigabyte. So to me, it's just like becomes a sport of just constructing systems in your head and just immediately being able to reason through how much this stuff is going to cost and what the performance would be. And I mean, I annoy my team with that as well, right? Where I'm like, okay, like this is taking 100 milliseconds, but just like, hey, I'm just like dumb database CEO over here. I ran a couple of numbers and multiplied 2 of them, and I'm getting 10 milliseconds. Where does that delta come from? Like, am I stupid, or is there an opportunity here? It's one of the two.
Yeah,
Not stupid.
Sick.
But I think the profiling versus napkin math is really, really important. And it came out of very direct experience at Shopify of just people being like, oh, the database can't do this fast, so we got to write our own database. Like, are you crazy? Like, you have not, like, this benchmark tells you, like, this benchmark is sharded by like a document ID. So it's like going to 64, like you have no idea what you're doing, right? Like you should never trust someone to do a database who can't just like rip things apart like this and understand exactly what the machine is doing.
People love an excuse to do their own database though.
Yeah, it's so good. That's why there are thousands of databases.
I don't blame them. I mean, it's fun, right?
The mental model I apply here in terms of napkin math to the kind of work that I do is, so when I look at a system, I assume that the latency of the system should be 0. Like I just assume it should be trivially fast. Like who cares? And then as I look into the system and I see, oh, there's 10 milliseconds there, there's 200 milliseconds there, I have to prove to myself or find out the bug in the code or the system why it's not trivially fast. So, if I find that something is taking 200 milliseconds, is this the flaw of the physics as proved by napkin math? Or is this a bug that can be fixed through some little tweak here or there?
I like that. That's a very Bayesian model of the system. And I think it also impacts of like, okay, taking away these 10 milliseconds is going to take like 1 engineering year, whereas taking away these like 100 milliseconds is going to take away 1 engineering week, which is a very practical trade-off in a lot of systems. Like I think you tweeted recently a company that was running their databases in a different region, right, as their workers. And this is it's just so common. And I think it's even more common in the AI era, because if I'm doing a call, like even for something like if I'm calling out to take a bunch of text and turn it into an embedding vector, it's just like none of these companies are publishing where the compute is. And the reason why they can't do that is because it's so hard to get GPUs. So they're just like, we're just happy to get the GPU anywhere it comes from. But it's like a very real like trade-off, right? On the other side, it's like you don't know if this request is going to end up in US East or US West. You just don't know.
There was someone a while back, I remember, that we took, I think a few of us joined in on taking them apart on Twitter. They did a benchmark where they basically were like, the headline was that PlanScale was slow. Not the recent one you were thinking about. This is a previous one. And what we discovered from looking at the benchmark was they were testing everyone else in like the same region, us in like a far away region, and the benchmark was doing a select one. So I explained to them, you might as well just ping the hosts. Like you are testing the network stack and the distance between these data centers. And it took an embarrassing amount of time to get it through to their head that they didn't even, the database literally just knows how to answer that in code. Like it doesn't ask the data for select one. The query planner and parser will just return that to you immediately. What was more embarrassing is I think it had done very well on Hacker News or something, and it was very sad to me that like hundreds, if not thousands, of people couldn't just sniff this out as being absolute trash in seconds. And this probably explains why so much of the web is slow, because people just don't take this critical thinking and don't know what they're truly testing. And it is a real nightmare to sell infrastructure in this environment, because like even when people say they're going to like do their own testing or whatever, unless it's like a company you trust, you just know that's going to be pretty rough to see that, right? But that's why Daniel's in business, keeps him in business.
Yeah, well, Daniel, thank you for your service, making the internet a better place for all of us.
Yeah, honestly, I don't think there's any shortage of work anytime soon for me.
Especially in the vibe coding era. That's going to
yeah, no, 100%. I mean, to be honest, just coming back to the cross-region latency problem, I see this coming from one of two things. Either people just don't know that they're setting up compute and databases in different regions. You know, it's just not clear in the UI or whatever. Or they actually think it's a feature where like they put a little bit of compute in one region, a little bit of compute in another, you know, for redundancy, keep the database in a different one, have load balances between them. And then they wonder why like the latency through the system is so spiky, not clear. Yeah.
If PlanetScale just ran on the edge, we wouldn't have any of these issues.
Oh yeah. If only we solved physics and just, you know, bent time so that you could do replication. Yes, that's it. Multi-master across the world. It'd be so easy, wouldn't it? It'd be so amazing.
Oh,
so amazing.
Yeah.
One day.
Incredible.
Or atomic clocks. Back to Jeff Dean. If only we could have atomic clocks everywhere. That would be much easier.
All right, guys. Well, I know a few of us have places we need to be next, but Daniel, I appreciate you coming on. It was a lot of fun chatting about performance. Maybe we should do this again sometime soon.
Yeah, for sure.
Yeah, come back, Daniel. It's good to. We want to learn more about your history and what you get up to with performance. Thank you for coming on. Appreciate you.
Yeah, thanks for coming, Daniel. Good to see you again.
Yeah,
cool.
Thanks, guys. Have a good day.
Bye.
And see everybody.
Bye, everyone.
Bye, everyone. Take care. Thank you. Have a good week. Bye.